Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video we're going to go through the second part of our examples, talking about the equivalent projection. We're talking about the equivalent projection. And so if you remember in our first video of the examples, we went through the process of step 1, converting everything from degrees to radians. And then we calculated the equidistant projection by going over here and simply plugging in the formula. So what we're going to do in this video is we're going to assume that we've already done step 1. So rather than going back and redoing all of those calculations, we're going to assume that we already have them. And we're going to skip right to step 2, where we plug this into the formula again for the equivalent projection using the radius of 3,959. So I'm going to scroll down here to where I've already copied over our step 1. I'm just going to make a reference for myself here that R is going to be equal to 3,500, and just to confirm here, 3,900, see, this is why you have to confirm things, 3,959 miles. And then we need to figure out what formulas are we talking about. Well, if you remember back to the video where we derived the equation for the equivalent projection, we said that our y-coordinate, which was our easting, we said that that was still going to be the radius that we're using, which again is the radius of the Earth here, times the lambda, or the longitude of the point that we're given. And we said that I'm sorry, this is x, not y. That's x. Our x is equal to our easting is equal to the radius of our reference globe times our longitude. And we said that our y, or our northing, right, if you remember back to the video, we said that this had a distortion in it. And that distortion was the cosine of theta. And so what we did is we accounted for that by integrating the northing with that term. And we got that the northing was going to be equal to the radius times the sine of theta. And again, theta being in radians. Okay. So if you don't remember how we got to this point here, I would go back and rewatch the video on the equation for an equivalent projection. Okay. And so now let's go ahead and plug in some values and get some results. So let's start with New York. So again, right, we have the value here in radians. This is our northing, so we're going to plug it into this equation first. So our y is going to be equal to r, which is 3,959, times the sine of our theta, which is 0.698. So what we can do is we can bring up our handy dandy calculator here, and we can type in 0.698, making sure that our calculator is in radians. We can take the sine of that to get 0.642. We can then multiply that value by 3,959 to get an answer of 2,544. I'm going to move this out of the way here so that I don't lose it. Okay, right. So if we do that math, we get a value of approximately 2,544 miles. Okay. Our x, well, that's going to be the exact same as what we had before. Right, that's going to be our r times our lambda. So our r is to be 3,959 times our lambda is going to be negative 1.241. And that is a really messy 4. And if you remember from our previous video, right, doing the math on that, we get negative 4,913 miles. Okay. So let's look at London. Okay. So London, we're going to do the exact same thing. Our y, which is going to be our northing, because we don't have to do the easting because it's 0. Right, the northing of our London is going to be equal to r sine theta, which is going to be equal, if you do the math on that, we'll bring our calculator back over here. Right, our theta is going to be equal to 0.89. If we take the sine of that, we get 0.777. If we multiply that by our radius, which is equal to 3959, we get a value of 3076. So this is going to be approximately equal to 3,076 miles. Okay, and again, in this case, our x is going to be 0 because our easting is 0. Okay. So let's scroll down a little bit and let's do Paris. Paris, we're going to do the exact same thing, right? Y equals our northing equals r sine of theta. Right, r sine of theta is going to simply be equal to the radius, so 3959 times the sine, and in this case it's going to be 0.855. And so if we bring over our handy dandy calculator, 0.855 trigonometry sine, 7.54. Let me multiply that by the 3959. We get 2,987, right? So this is going to be approximately equal to 2,987 miles, right? And then finally, right, the x value for Paris is going to equal the easting, which we already said was the r times the longitude, or lambda. And if you remember back from the previous video, right, the value that gave us was approximately 139 miles. Okay. So again, to recap what we did here, all we did was we took the angle measured in radians and we plugged it into the equation that we calculated in the previous video for the equivalent projection, using r sine theta for northing and r lambda for easting. Hopefully this made sense. If you have any questions, please reach out. Thank you.